Okay, everybody, this is chapter 12, section 1. This is dealing with circles. Um, there's a lot of vocabulary here, so I'll pull them all up, and then once I get them all up, why don't you hit pause, and then you can go ahead and write them all down, then I'll start it again, okay? So here we go. A circle is a set of points equidistant from a center, so we'll call that C. And then we got all these other definitions go with it. Some of you already know. A couple of them are new, okay? So if you go ahead and hit pause and go ahead and write all those down, and then we'll get going. So you see in the circle then, if you could take all these and draw them in and label them. You know, we did trig a while ago, and we had the word tangent. That's a trig function, but tangent in this sense deals with a specific line that will intersect a circle. So that's this kind of, there's a point right there where that tangent's touching just a point on the circle. Okay, so a little bit of a different definition with that word than what we're kind of used to. Okay, secant is another one down here at the bottom that is another trig term that we haven't used. You'll hear that in some other higher math classes, but in this case, a secant is just a line that will intersect a circle, but it keeps on going forever, and it'll intersect a circle at two places. Okay, but this one goes through the circle. It's similar to what a chord is, but a chord has endpoints. It actually ends on the 2 points of the circle. Okay, a diameter is a chord. Okay, but it's more specific because it goes through the center of the circle, still hitting the circle at 2 points on the outside, but it has to go through the center. Okay, so we got some things that are kind of similar here, and some things that have really specific needs or names, like hypotenuse is going to be the longest leg of a right triangle. So that's kind of what a diameter and chord and secant kind of have the same similarities, but some very specific differences. Okay, so we go down through some of these examples down here at the bottom. We just need to kind of pick which one's which. So AD is right here, and it's touching the circle at 2 points, but it goes through the center. So I think that's going to be diameter. Let's see if that's right. Check mark says yes. CD is this right here. So that's going from C to D. That's going from the center of the circle to a point. I think that's a radius. So let's find out. And it is. Excellent. GK, now it says line GK. So line GK is doing this. It's going through the circle, but it's continuing on. And we need to make sure that, you know, we understand that it's continuing on, it's not stopping. So I think if I go back to my definitions, I think that's a secant. Let's find out. We're correct there. EG is also a line. EG is doing this. Now, it's not really very apparent to me that it's touching at 1 point, but I think it probably is. So that definition was a tangent. So we'll kind of look there. We were right. Excellent. And then last one, you know, we could kind of do that. But HB is actually stopping on the circle. So HB to me would be a chord. Okay. So, and that was the last one. So process of elimination anyway, but we'll talk about it. Okay. So there's some of your definitions, and going, you know, with that picture. Okay. All right, so down here we got 3 different definitions. A common tangent is kind of like the umbrella one. So for this one, I'll pull all these out. Why don't you go ahead and write your definitions in. You could hit pause while you're writing. and then we'll kind of go over this a little bit. I don't like the last definition, not very scientific there, but we'll explain it, okay? Okay, so then we'll use this common tangent just up here in the top two circles. I got two circles, and if we remember, a line that's tangent to a circle touches it at one point, okay? So I'm going to try to draw a line here that's going to touch each circle at one point, kind of like at the same time. So that's a common tangent. It's touching, in this case, two circles. You could probably make a case that can touch as many circles as possible, but it's got to be a line that's tangent. So that means it's touching each circle at one point. And sometimes you label it. So let's go ahead. We'll label it A and we'll label it B. Okay. All right. Now, a common internal tangent intersects the segment that's connecting the centers. So this one's really different here. Let's take the definition kind of as it is. There's a line that will connect the centers of the circles. I didn't do a very good job of drawing that. See if I can make them actually touch. There we go. Kind of touch. Okay. So that's a line that connects the two centers of the circles. A common internal tangent will be tangent to both the circles, but it intersects the line that connected the two centers. So kind of a busy kind of word or definition there. And that's not the only one. I can actually draw another line doing this that's intersecting the circle, or that line that connects the center and tangent to the circle. So that's what common internal means. All right. So that's on a test. It's a definition you got to know. You just got to memorize that. Okay. A common external tangent. Well, the definition tells us it doesn't do that, and let's just draw that then. Okay. So I'm going to draw a line that one connects the two centers of the circle. Okay. A common internal tangent will not intersect that line. So that would be kind of like the first definition we did with a common tangent. It's going to do, we have a common tangent line, it's intersecting the two circles at one point, but it does not intersect this line. Okay, so just you got to keep those two straight. Not too difficult, I hope, and it's just a definition shows up on your test. Okay. All right, let's move on. A point of tangency. So we kind of talked about that, but we're going to kind of throw some new stuff at you here. And this one's really stuff you have to know. This says a point where a line is tangent to a circle, or a point where it touches the circle. Okay. Now with that definition, there's a couple of theorems that are big time here that we got to have. Okay. So if a line is tangent to a circle, then it's perpendicular to the radius that's drawn to that point of tangency. Well, let's draw a circle here and kind of illustrate this a little bit. Okay, so let's draw a circle. Let's draw a radius, and we'll just kind of, for our sake, we'll draw it looking like that. So there's my radius. All right, if you want to label it, you can. I don't have a whole lot of room here. Now what I'm going to do is I'm going to draw a line that's tangent to this point where the radius is touching the circle. Okay, and they're telling me that anytime I do that, I'm going to be perpendicular to that radius. So let's show that it's at a 90-degree angle, and that's a really big definition. Okay, and you'll see why in a second. And then this is kind of just like the converse here. Okay, so we're just kind of saying it backwards again. If a line is perpendicular to the radius of a circle at its endpoint on the circle, a lot of words there, then the line's tangent. So it's somehow you're able to see or prove that it's perpendicular, then you can say it's tangent. Okay? So hopefully that helps you out. Now what it does is, if you look at these two examples really quick before we're doing that, if these are going to be perpendicular, so it'll be perpendicular here if they are tangent, then if you'll notice, do I have right triangles? And so since August, all the way until the end of the year, we've always worked with Pythagorean theorem. So I can use the Pythagorean theorem in this case to be able to prove, is the line tangent? So if I stick everything into my formula and I get each side to be equal to each side, then it proves that the line's tangent to the circle, or it's intersecting that radius at 90 degrees, okay? So what I'll have you guys do, this is a yes or no question. I'll have you plug everything into the Pythagorean theorem. Does it come out to be equal or not? If it's equal, it's a right triangle, it's tangent. If it's not equal, it's not a right triangle, so therefore it's not tangent, okay? So if you want to hit pause and try these two, and I'll put the problems up, or the formula up on the board, okay? Okay, so here's the work for you. You know, you gotta go back. And remember that your longest leg is going to be your C. So plugging everything in, I get 121 plus 3600 equals 3721 for A. And when I add these two on the left-hand side, it ends up being equal. So it's a big fat yes, it is tangent to the circle, because it shows that this point right here is perpendicular, okay? If I go to example B and I plug everything in, it does not come out to be equal. So that line FE is not tangent to the circle. It's probably touching it really at 2 points, just can't really see it. But because it's not equal, it's not tangent, so it's a big fat no, okay? All right, kind of going a little bit more onto that last definition. We got another theorem. If two segments from the same exterior point, so this point out here, exterior, outside, are tangent to a circle, so I'm assuming that this line's tangent there and the second line's tangent there, then that says that these two lines should be congruent. So if I look here and here, that could say that those are congruent. Well, how do I solve it for x? Well, if they're equal, then shouldn't I be able to set them equal to each other? So that means I can go ahead and go x squared plus 2 equals 11. And I can solve that. So why don't you go ahead and try to do that one? So I subtracted 2 from both sides. I get this. I'm going to now have to take the square root of both sides, and I get x equals 3. Okay. Let's see if we were right, and we were right. It does say plus or minus 3. I'm going to reject the negative number just because I'm working with a length, and I should always have positive, but -3 would make it true also. Okay. All right. So this is a test question down. That was a test question, and then we got this one down here that's also a test question. And you know, my big thing is draw it. Okay, so let's draw this together. I got a tangent that's drawn to a circle from a point 13 centimeters from the center of the circle. If the radius is 5 centimeters, what's the length of the tangent? Okay, so this is kind of, the wording here is really tricky. So let's draw a circle, and let's put the center. And we have a tangent that's drawn to a circle from a point 13 centimeters from the center of the circle. So let's just draw a line, and let's just say it's 13. Okay. Now that's not tangent. I know it's touching the circle here at one point, but it's also then continuing on into the center. So that's really not tangent. So what I'm going to do is, from this point out here, I'm going to draw a line that I'm going to call tangent. So it's going to be to there. Okay. So I don't know how long that is. Okay. And then they tell me I have a radius that's 5 centimeters long. Well, this is 5 centimeters because that's a radius because it's drawn from the center, but I can draw another radius that's still 5 centimeters long. Okay. So, and if you know, they told me it's tangent, so that means that this is a right angle up here. Well, now I can use kind of Pythagorean theorem here to find how long that tangent line is, because that's what they're asking. Okay, so really the wording here is a little tricky, and this question shows up again, so I want to make sure that we do that. We can ignore this 5, okay, because that really, I was just kind of using that to illustrate. It's not, that wasn't the tangent line. The tangent line was X. Okay, so I'll let you guys go ahead and set up your Pythagorean theorem. Now remember that 13 is going to be your C. Okay, so why don't you go ahead and do that, and then I'll put it up on the board. Okay, so plugging all that in, I get all that. Sorry about my writing here. That's a 6. I subtracted it. I took the square root of both sides, and I get x equals plus or minus 12, but I am dealing with a length, and that has to be positive, so I reject the negative value. Okay, so that's how you do that one. Make sure you kind of put a star next to that or notate that. That's a test question right there, and the wording gets kind of tricky. Okay, all right, thanks a lot.